I'm pleased to introduce today's presenter, Dr. Christopher Herring. Chris is a research physical scientist with the River Engineering Branch at Engineering Research and Development Center, U.S. Army Corps of Engineers. He has over 25 years of experience in fluvial geomorphology, hydrology, hydraulics, river engineering, and river and stream restoration and stabilization. His work experience includes studies in hydrologic and hydraulic analysis of watersheds, geomorphic watershed assessments, wildfire recovery, riverbed and bank stabilization studies, and projects using grade control structures, and redirective and bank erosion control measures in combination with engineering with nature, natural and nature-based features, which we'll call EWN for short. He's the Army Corps lead for developing the International Fluvial EWN Guidelines Manual, working with partners from the UK, Netherlands, and others. He continues to work in the EWN working groups to develop technical notes and reports, documenting initiatives and applications. He also serves on the Army Corps River Engineering Committee that aids Corps districts in solving water resource and river engineering problems. In addition, he has also been responsible for conducting geomorphic and river engineering research and developing and teaching training courses and workshops for the Army Corps and other federal, state, and local agencies throughout the U.S. We're so pleased to have Chris with us today, and with that, I'll turn it over to him.
Thank you, Rachel. Can you hear me?
We can hear you.
All right, well, we will get started then. I will share my presentation. You can see that all right, Rachel?
Not seeing it yet. Go ahead and try sharing one more time.
Okay. I think I got it this time. Is that good?
Looks perfect.
All right. Well, thank you for the introduction, Rachel. It's a pleasure to be on with this group, not morning, but early afternoon. And a special thanks to the Southwest Fire Science Consortium and University of Northern Arizona School of Forestry Wildfire Initiative for hosting this webinar. The information that I'm going to go through is important information. I think probably the majority of folks that participate in these webinars have some pretty good background on the majority of things that I will be talking about. But I think this gives an opportunity to give a little bit different twist, maybe from a USACE, U.S. Army Corps of Engineers perspective, where we've really tried to advance our internal engineering background and portfolios with incorporating more nature-based approaches. And so I think with wildfire recovery and other opportunities with civil works projects and support to the military, we have just endless opportunities to work with our partners and to conduct research and future projects using this engineering with nature, natural and nature-based features approach. Without ado, then I will get into the presentation. Just a brief agenda here this morning, or this afternoon. Sorry, I said this morning because we just passed the noon threshold. Talk a little bit about the EWN initiative and give a little background onto what the backbone of the program is and how we're initiating that through the core districts. Talk in some detail about the Santa Clara Canyon wildfire and discuss some of the initial recovery efforts completed after the wildfire event in 2011. And then talk more about some of the continuing recovery efforts that the Santa Clara Pueblo is continuing to work with not just the Corps of Engineers, but a wide range of groups to continue to implement recovery efforts. So what is engineering with nature? The title in and of itself seems fairly similar or simplistic, I guess, and maybe similar to a lot of other approaches. I know FEMA has growing greener or greening aspects of some of their program titles. Housing and Urban Development also has some kind of green initiatives to kind of move forward. But the engineering with nature perspective started back in the early 2010s with some of the work we had started after hurricane recovery efforts. And just as an example, and I won't get into any specifics, but one of the things there was some studies that were completed by some insurance companies, kind of a consortium of insurance companies after some hurricane damage along the coast. And what they were finding is that some of these natural areas that had salt marshes and wetland areas were recovering and had a lot less damage to the infrastructure from these hurricane events. And you know, maybe a few spots here and there wouldn't be a big deal, but this was pretty much endemic from these hurricane damages. So it was really a group of non-governmental agencies, groups, and entities that got together and kind of did this research. And so that kind of got the wheels turning within the Corps, thinking about, well, if there's approaches that we can do to better understand nature and to incorporate it into our designs, then we really need to be thinking about that for future projects. And I will say, to a certain extent, this isn't necessarily all new, because I think, you know, to the credit of our researchers and our engineering designs in the past, we have done, you know, some engineering concepts in the past, but maybe not as much focus as what we could. And so I think it's a good way to reflect on making adjustments and making changes to better further our design protocols, but then also our funding mechanisms and how we get and proceed with projects. So just quickly, a few of the key elements of engineering with nature. We want to be thinking about science and engineering and how those mix together to provide operational efficiencies. We certainly want to be thinking about natural processes and how we can maximize those benefits. And then I think for any folks that are involved with USACE projects in the past, sometimes we're kind of caught in this benefit cost ratio world where we're not considering the wide range of benefits that we are actually occurring, or that are occurring through our projects. So trying to think about it is maybe more of a whole box approach and not just a small box where we're looking at other benefits ancillary benefits that come from the work we're doing. And then a science-based collaborative approach process. This is really, I think, kind of the backbone of how we want to proceed with these type of projects, not just other federal partners, but stakeholders. Obviously, we work with a lot of different local stakeholders. In the example we'll talk about today, it's the Santa Clara Pueblo, and helping them recover from the wildfire effects. But it's also municipalities, it's townships, it's other partners, NGOs that have a stake in trying to do restoration, stabilization, and furthering some of these natural processes within our design concepts. So key elements. These are those 4 key elements that I just mentioned. And I think the broad brush here is that we have a degree of which we can use each one of these elements depending on the site-specific characteristics of our project, our watershed, and then the scalability of the types of things that we're looking at doing. A small project, maybe to protect a bridge or a roadway or something, will have maybe some different key elements. Maybe there's more science and engineering based because there's already well-established practices we would use to treat that site-specific location. Whereas if we've got a larger watershed approach, maybe there's different characteristics within some of those smaller tributary watersheds that we would lean more on science and engineering, and maybe even more collaborative. Maybe there's some university research that's kind of brought the ball forward in more watershed assessment approaches and stuff. And so this figure is really just kind of showing these EWN elements can be variable depending on the application and the specific project that we're working on, which I think in general is pretty exciting, because if we had every project that had all the same components and all the same processes, then it would be, well, I won't say easy, but it would be a lot simpler to look at. And so we've got to be thinking about how these different elements work and how we can optimize each one of these elements. And then I always profess, and if you see this other places, I'm sure I don't have a trademark on this, but my approach is always a systems approach, where we're not just looking at one site-specific location, but trying to figure out the physical processes of why we're having issues, and what are the overall instability issues with maybe the channel, the watershed. Obviously, with the Santa Clara Pueblo, we've got widespread stability issues because of some of the wildfire effects to the watershed. But other locations, downstream of the Santa Clara Pueblo on the Rio Grande, are there some other areas where we have levees, or we have some other areas where we could potentially enhance some of the habitat, some of the benefits by maybe putting in specific structures to help stabilize or reintroduce a floodplain, or provide more flow to a floodplain so that we get nutrient recycling and those kind of aspects. So thinking about it in a systems approach and not just kind of pigeonholing, I guess is what we would say, to just site-specific benefits. And that approach a lot of times is very difficult because we have so many different sponsors along a different trajectory. And again, that's kind of where I'm talking about scale. In a large watershed, it might be very hard to get a lot of folks on board, but thinking about the systems approach, at least then we can kind of optimize how we bring in those key elements of the engineering with nature approach. And this is my favorite figure. This is a figure that Dr. David Biedenhorn and I have come up with in trying to kind of elaborate on how we apply certain natural and nature-based features, kind of a component of the EWN, where we're looking at different approaches to apply to different situations. The example here is basically your range of stabilization techniques. And this is pretty specific in the fact that, we've got really hard, full armored bank material on, or bed material on the right side of this bell curve. And then on the left, we have just purely vegetative. Well, the majority of our projects are really probably somewhere in the middle. And you can certainly argue that maybe some agencies and maybe even the Corps in the past for sure has really kind of tailored towards that full armor, full bank armor, or structures to the right. But there is also some other components of this, and that is factor of safety. How robust do you need to build the structures to make sure that we don't lose the actual purpose of the project. And so there may be projects where we have to really lean towards that full bank armor. But there's other opportunities too, where we can maybe look at the purely vegetative techniques, where we don't have a lot of risk. We don't have roadways, we don't have bridges, we don't have critical infrastructure. So the factor of safety could be a lot lower. Couple examples here in this photo, and I won't go over all of them, but the upper left hand there, above the pure vegetative techniques symbol sign, this was a photo that I took back in 2017 on the Santa Clara Pueblo, and this was one of the trees that had fallen after the kind of erosion events, and it had stabilized a section of the river. Now that might be temporarily stabilizing, but it gets you thinking about potentially using some of the in situ materials to stabilize these channels. This was a good example of where nature was kind of doing what it wanted to stabilize things. Now, is it going to last for 50 years? I don't know. Maybe there would be some kind of design that we could incorporate. In fact, I know there would be a design that we can incorporate using that same wood and maybe some other materials. And that might tip it back towards the center of this curve, but at least then we're getting more maybe bang for our buck. We're mixing in those woody materials and maybe some rock or some other in situ materials there, but we're getting a good design so that it stays in place and stabilizes how we need it. Again, in a systems approach to this type of stabilization. And then just finally, I think the lower right-hand corner of the slide, you can see what is a gabion basket. I'll call them full valley grade control structures. There were multiple structures like this put in the Santa Clara Pueblo pretty quickly after the event to start catching a lot of the sediment that was coming and being derived from the upper parts of the canyon. Now, while these structures are very ugly, they are definitely fish barriers and to any kind of passage. The immediate need for these type of structures and preventing that sediment from being delivered downstream to the alluvial fan and where the population base is was very important. And so, again, in some cases, just hard structures need to be used. I guess my focus, though, would be to this group and to others is, are there some things now? And Garrett Altman with the Santa Clara Pueblo, been working with him on looking at some kind of options potentially now that the system has settled down to a certain extent. Is there ways that we can modify these structures now after 10 years plus of being in and really stabilizing this valley? So I think that's the challenge, is kind of a phased approach, that when we have to use these hard engineered structures, is there a time in the future where we can actually come back and maybe modify those structures to help not only aesthetically, but just fundamentally help the structure, because these structures do have a lifespan with the materials that are in use. And then from a natural materials perspective, ERDIC, the Coastal Hydraulics Lab, the Environmental Lab, Geotechnical and Structures Lab, we all do research on using types of materials in different applications. In this case, we can see some of the wood debris materials in a flume up in the left-hand corner, and then the physical applications of them in the field to the lower left. And then grade control using rock materials, but then also other materials in the center, lower center photo, shows different applications potentially for some of our urbanized areas where we're trying to provide stability to the watersheds, but then also not make everything just like a concrete line channel. Can we use these different approaches? And the answer is yes, in some cases. Now, again, when we get into flood risk management projects, we may have the need for a higher factor of safety. So we always have to consider that. And then over on the right-hand, lower right-hand corner is some vegetative replantings on a coastal setting. That is not my strong suit, but I wanted to include that in here as not just kind of the inland perspective, but there is a lot of information from a natural and nature-based features approach to using vegetation and woody materials. So we'll start with the Santa Clara Pueblo, really the main discussion today, and going back to look at a kind of when this issue started, and I'll do it as much justice as I can. I have to give a lot of kudos to the Albuquerque Army Corps of Engineers district. They supported the Santa Clara Pueblo during the 2000 or after the 2011 wildfire event, and did an amazing job of engineering and planning and assistance to the Pueblo. And with that, I would say it wasn't just the Corps of Engineers, it was an entire group of other federal partners and state and local groups that really, really made a difference. And I would let Garrett Altman or somebody from the Pueblo kind of speak more on that. But I know in the meetings and the past workshops we've had, the last one being late September, this group has really made strides in the 10 years plus that this group has kind of been working together. Just a little bit of background. You can see in the photo or the figure here of the aerial photo. This is the Santa Clara Pueblo Canyon, and it's about a 19-mile long canyon. The top end is to the west, to the left of the photo there, kind of the mountain ranges kind of around that top end, and the steepness of the slopes obviously are steeper up in that upper part of the canyon. As you progress down to the east, then the canyon comes down into the city of Espanola, and finally then drains into the Rio Grande, and the Rio Grande is running basically from north to south there on the kind of the right side of your photo. For reference, then Los Alamos is kind of in the center, lower left center of the photo. And so the 2011 burn was near total burn. One of the real big issues with the erosion and the need for stabilization was the 100-year was basically calibrated based on loss of vegetation to so this is the 1% chance rain event after the wildfire increased 400% the peak flow runoff conditions compared to pre-fire conditions. So you can imagine on these steep slopes, when you have that much of an increase in runoff rates, you're going to have a lot of erosion, just tremendous amounts, tons and tons of materials starting to leave these slopes. Unfortunately, one of the other issues with this wildfire was the effects it had on the Pueblo. This was a cultural significant area, the entire canyon. And so the loss of access to this location was just tremendous. And talking with a few folks from the Pueblo, it's very hard situation for them. And then also, as I recall, there was a specific trout species in the upper part of the canyon that they had just kind of identified that had some specific genetic, I guess, specialty. And the trout species was lost too as a result of this wildfire. So just tremendous amounts of loss. I don't think that can be overstated. So I got a few photos here. This was from 2017 when I visited. So this is about 5-6 years after the event. And so there had been some structures, and we'll talk about those here in just a minute. But I wanted to show a few photos of just, some of the conditions that were still very active in 2017 when I was visiting the Pueblo as part of a dredging operations technical support program to do some field reconnaissance. So you can just see tremendous amounts of sediment. This is a large tree. This was the tree I had a photo of earlier that had fallen and it stabilized things upstream. As that tree decays, now it's caught a lot of material back behind, and so that channel has, to a certain extent, stabilized immediately upstream. But if that tree decays now, then we start, re-eroding just that local vicinity. So the question is, can we design some structures? Can we re-meander the channel? Can we deal with the sediment that's coming down? And sediment continuity from a design perspective is of utmost importance when we're considering channel restoration. And some of the tributaries, tremendous amounts of sediment, and the photo here shows the upper left, shows one of the tributaries. I think this is Switchback Canyon, that has just tremendous amounts. In many of these eroding channels, there were very few, if any, defined channels pre-wildfire. And so, for example, this photo showing this one tributary, the original tributary was up as far as the base level of this channel was up where the green vegetation is now, and this is eroded in some cases down 20 to 30 feet and 50 to 75 feet wide in some locations. And so tremendous amounts of sediment being delivered from these tributaries as they basically progress through this geomorphic change. So initial recovery efforts from the Santa Clara Pueblo planning perspective, again, this was coordination with the Albuquerque Corps of Engineers and some other groups as well, NRCS in particular. But this map in particular shows some of those aspects, and I'm not sure you can see all these on your screen, but fuel breaks, revegetation, some of the contour tree felling that NRCS was doing. That's in, I think, yellow or orange in some of the upper parts of the watershed. In channel restoration on the tributaries, just tremendous amounts of structures. I think there was over 5,000 structures put in on these tributaries, the majority of them by hand. There were some debris structures, and I'll show some photos of those here in a few minutes, that were also installed as well as part of kind of the comprehensive approach. So sediment collection structures, I mentioned earlier the gabion basket, basically grade control structures. And what these are basically rock baskets that are filled with rock. And then they're stacked and kind of built up to provide storage capacity for the sediment that's being delivered from upstream. So you can see in the lower left and the lower right photo here, these are those structures, and behind this is all filled up with sediment. And when those structures were put in, the sediment was not up to the top of these structures. So they've done their job. They've collected a lot of sediment. But one of the things when you collect a lot of sediment, sometimes the system adjusts and then we start degradation or scouring downstream because we've caught so much. And so there is a balance. And again, I think the approach potentially is how can we maybe modify these structures in the future? And then the debris barriers, these are very common in Europe, in some of the mountainous regions, and in the Western US states as well. These are basically netting structures that are anchored in to catch sediment coming off the tributaries to keep them out of the main stem. And as a component of that kind of immediate approach as well, when we're having all this material delivered from the upstream reaches and the watershed, those gabion basket structures do catch a lot of material, but there is so much pulsing through the system that the lower sections around Espanola were having tremendous amounts of sediment being delivered as well. So there were some modifications to some of the road culverts. The upper right-hand photo here, you can see HESCO barriers, HESCO baskets that were put in for flood control. Because when you have sediment that fills in the channel, then you lose your capacity once your water flows come up. And so you have a potential to flood at more frequent events. And so there's a balance from a flood risk management perspective. And many times that's hard to figure out that channel balance between sediment and flow and elevation for, I'll say, protection, which we don't necessarily like to use protection, maybe mitigation of flood events. But as that sediment's coming down, that fills in your channel, and you may lose some of the benefits you had previous. So a lot of work done down in the lower sections with flood risk management type projects too. So continuing the wildfire recovery efforts in 2017, and so a lot of this, the work that I just showed you here was done kind of immediately and kind of preliminary up until about 2017. And my office at ERDIC, River Engineering Branch, was contacted to kind of go out and assess some of these practices and how they were functioning. And we're still in the process of doing that. But from a engineering with nature perspective, these locations are very hard to get at. Even if you could get materials up to these locations in these tributaries and equipment, it's just really hard to function on that slope. And so there was a group from the Pueblo, some different working groups that constructed basically in situ material structures, wood structures, and rock structures in these tributaries. And to what we were looking at then back in about 2017, when we first made my first visit, was to assess these structures and see how they were functioning, and if there was any kind of modifications that we could look at or suggest to the construction groups. And so what we came up with, again, thinking about this systems approach, what is important to the Pueblo, and reestablishing roadways is one of them, egress and regress routes. And this ties into the emergency action plan. When you're in canyons like this, if you have heavy rainfall events, there's in some locations where the canyons get tight, you may only have access to get out very quickly. And so you got to be thinking about having safe egress, regress. And so that's something that's still ongoing. We did look at the channel stabilization measures and looked at what we call traditional ecological knowledge. And that is basically the Pueblo's expertise, the ideas of vegetation, of using in situ materials, and how those materials can be used to stabilize different aspects of the watershed. And so traditional ecological knowledge has really become a big focus within the Corps, and really for a great reason, because if there are natural and nature-based features that we can incorporate into our designs, then we really need to be learning those and making sure that we're able to apply that information as appropriate as possible. And then there's another list here, I guess the final list here of some of the things that we looked at. Had some modification recommendations to some of the wood structures and the rock structures as far as flanking. Livestock exclusion was another kind of suggestion because with vegetation, it's hard to get vegetation reestablished in some of these corridors if we've got livestock issues or over too many head of cattle or something, depending on what kind of livestock it is. And then always continuing to monitor these watersheds and for sediment pulses and issues with stabilization measures that we've put in. And so the EWN project then started in 2020, really focusing on some of the aspects of what we came up with in 2017 from a perspective of monitoring and what are the practices that the Pueblo has been doing that are really, really working, and maybe even what practices might not be working. And so we did put together a tech journal article in the lower right-hand corner here. I think the reference is there as well. But looking at these traditional ecological knowledge applications and how they work within the context of the Pueblo. And we looked at some of these wetland complexes that they were working on restoring. In particular, this bottomless culvert perspective, and this isn't necessarily anything that's new, but it is maybe an application that hasn't been widespread. And by using these bottomless culverts, basically you're filling the bottom of the culvert, you're losing capacity, so the culvert has to be designed appropriately, but you're providing access fish passage through these where we have the natural materials. And also, within the canyon, there's a lot of seeps and springs that pop out, some of which may be some old oxbows that have been buried. But the lower left-hand photo here, you can see there's the channel was actually restored back over so that there's a floodplain now on the outside of the meander bend, and that fowag, the deepest part of the channel, isn't eroding against the bank, the steep bank. And also what you can see here is some floodplain mulching, using the materials, again, in situ materials, and kind of breaking them up, mulching them to provide more organic material and erosion resistant material. In some cases, they stake these down because one of the issues with these soils is, again, the organics are pretty low after the wildfire. So if we can get some organics back into the soils right where they need them, then we've got an opportunity to provide better access for vegetation to reestablish. And then I've got a few slides here showing some of these wood structures with rock. These photos were from 2017 during some of the construction. You can see on the right-hand photo there, there's locked kind of logs that were structured across with rocks. And again, part of our focus on these type of structures was, is there some modifications we can do? Here's another couple of structures and how they're installed to prevent flanking and even, maybe degradation from downstream. The lower right-hand photo has some kind of just simple logs locked in with willow cuttings as well. And interestingly, I'll show some photos here of where these willows are in 2021. So another aspect of what the Pueblo was really looking at was they had a series of ponds, 4 ponds up the canyon. And these ponds were used exclusively for fishing and aesthetics and cultural Pueblo purposes. And so these ponds have been wiped out. And so how can we reestablish these ponds and through wetland seeps, maybe some scrapes and some excavated pond locations? One of the things that was shared with me as well was, well, if we develop this pond, it can be used potentially as for a water source during any other kind of wildfires. And so that's a huge benefit, maybe that we don't think about a lot of times, is reestablishing those options for treating wildfire. Lower left here is some of the contour mulching in the upper part of the watershed that NRCS completed fairly early on in the first 4 to 5 years. And then the lower right-hand photo here is some of the restoration that's done in certain locations on the main stem. One of the main focuses of our 2017 report was to try to get a handle on the sediment coming out of the tributaries first. Not spending a lot of money on restoring the main stem until we get a handle on the sediment that's coming off of these tributaries. As part of that component, as well as the egress regress, culverts and crossings are of utmost importance when we're determining what type of grade line we're going to have in restoration for the main stem. And so until we get that focused kind of design put together, we really need to be careful about how much work we do in the main stem without getting control of the sediment in the tributaries, and then also knowing what our control inverts will be on our crossings and where they will be located. So some continuing recovery efforts here. The upper right-hand photo here, you can see some structures in the channel, and these were put in by some of the crews as well. And then the lower photo here, I'm actually standing on a culvert. Again, these culverts are very important as to how we reestablish these and how we're going to control that energy grade line going up through the channel for stream restoration, but revegetation as well. And you can see a lot of vegetation coming back into these areas. Now, some of these locations were planted, but then also some of it is just natural regeneration coming back now, 10 plus years after the wildfire. And this is from September of 2023, when we were there at the workshop. This is Switchback Canyon. Showing a lot of those willows coming up in these channels. There's one of the wood structures that were constructed back in 2017 or earlier. And so you can see a lot of vegetation coming up and really kind of stabilizing these tributaries. The big question is the flows that we've had since these structures were put in. Seems like there, in some of these locations, there hasn't been a lot of flow yet. So that's something we're monitoring and trying to make sure that we're understanding these structures and that they are functioning as best as they can. Are there some more modifications that we could make? And this figure then talks more about to the wetland kind of pond component. The photo down in the lower section of this slide is one of the most beautiful slide or pictures that I've ever taken. This is just from my camera phone. Just a beautiful area. And this is, I believe this is the upstream most pond, fourth pond, where that was located. And so they've got some plans to potentially do some modifications and really try to reestablish the cultural significance and the aesthetics of this location. And then revegetation, the upper right-hand photo there, if you look up on the left of that photo, there's just all kinds of revegetation. I believe it was alders that were coming in on that slope, just up on that alluvial fan. So, building progress. The vision of EWN, of natural and nature-based features, is to work collaboratively with our partners, with our sponsors, and really make sure that we're producing the best projects we can and making them sustainable and resilient through our considerations in working with nature. and really harnessing the power of collaboration with universities, with the partners, with the NGOs and other folks that are doing this type of work, making sure that we've got a full plate when we come to the party, and we're not just kind of coming as this is what we've done in the past, this is what we always do. Thinking about more of a natural approach. Again, always caveating that where we can, we will really try to move towards an engineering with nature perspective. And there may be some aspects where we just have to have hard structure and factor of safety, a higher factor of safety. But I think as we move forward, we're working on additional engineering with nature guidance and natural and nature-based features approaches. And so I think there's really some good things to come even further with these partnerships. This last slide I wanted to just mention, this is the international guidelines, EWN-NNBF document that was, I believe, started back in 2015 from a coastal perspective. I got involved with it in 2018 from a fluvial inland perspective. And then the document was, I think it's about 24 chapters, and there's 5 chapters of inland fluvial applications. So the webpage is here, but just a big group of, again, NGOs, universities, some of the business partners that are interested in these type of applications, to make sure that we're, again, considering natural and nature-based features in our designs, and working with nature and not against nature. So with that, I will take questions. This photo, I'm just, and maybe I shouldn't say, I'm just amazed at the photos that I can get with my camera phone these days. The color contrasts. This photo shows some of the rock structures that they've put in a few locations by hand on the main stem of the Santa Clara Creek, and some of the vegetation that's coming in and has been planted. So with that, I'll take some questions.
Great. Thank you so much for that really excellent presentation, Chris. And we can stay on a few minutes past the top of the hour if folks have some good conversation going. So we'll jump straight into the questions, starting with one from Jeff asking, was directional falling used on hillsides to reduce sediment transport? And if so, how effective was it?
I missed the beginning of that question. I'm sorry.
Was directional felling used on hillsides to reduce sediment transport, and how effective was it? So,
yeah, so I didn't do any specific direct measurements on that. My perspective, at least from what we saw, was the directional felling where it wasn't specific, where it was used across the kind of a broad meadow. Things looked really well. And then when we get closer to the tributary kind of steeper sections that go into channels, that's where we might have some issues. But I didn't do any specific, any calibration on that.
Okay, and there are a bunch of resources in the chat if folks want to check out more information through some of the links that Chris shared. So both Bruce and Alex were wondering about beavers, which is always a popular topic. Are they considered NNBF, and are you incorporating beaver dam analogs at this point, or trying to plan for some kind of beaver reintroduction to help with restoration? Or is that something that would be a second tier phase for later in the restoration process?
Yeah, and so the answer is yes, and yes. We are, I shouldn't say we, I think working with Garrett Altman and the Pueblo, that is something that they have been considering. I think the issue at this point has been actually the vegetation. Having enough vegetation to sustain the beaver populations, I think, has been maybe one of the at least issues they were thinking could be an issue. But the conversations that we've had is that they are considering the reintroduction of beavers to the Santa Clara Pueblo. From a core perspective, beaver dam analogies are typically maybe up in a watershed more so, where it would be more NRCS applications, but it's definitely something that's in our toolbox to be considering or even recommending to those areas, where it's applicable. Certainly there's maybe more applicability in some of the upland meadow areas in the Northwest states or the Southwest. If you're in the Midwest, where you've got a lot of agricultural areas, beavers may not be an option. But I think, it's, again, considering our kind of constraints and our limitations and trying to work with those where we can to try to reintroduce that natural process. So hopefully that answers the question.
Yeah, it sounds like the gist of it is there's interest, but it might be further down the line that it actually happens when there's an environment that can
certainly for the Santa Clara Pueblo.
Great. So we have a question from Jake that has to do with kind of how realistic this kind of work is, saying that this kind of work supports floodplain reconnection as watershed restoration, but the work is challenging with the time required and funding in most grant cycles. So most grants are 2 to 5 years in length and therefore don't provide sufficient time or funding to model the benefits of work in the existing floodplain or by raising the channel to reconnect the floodplain. All of this leading to the question, will there be any changes that reduce the roadblocks to raising the channel and promoting floodplain reconnection in mapped FEMA floodplains?
Yeah, I mean, I understand the context of the question. I'm not sure that I can answer for FEMA and what they would be requiring. I guess suffice it to say, I would hope that we can work with other federal partners, other local and state partners to try to limit these constraints when it comes to this type of stabilization restoration. But yeah, I can't speak for what FEMA might be able to do or not to do.
Okay, and for Jake and Jeff and some other folks, I will say Lindsay Quam, who I'm always happy to see you on the call, has put some good information in the chat. So Bill just asked, where are we now? How much is left to be done? Are there more structures that is needed? Basically, where does it go from here?
Yeah, so there's still a lot of work to be done in the Santa Clara Pueblo, and I would really like, I guess, Garrett Altman to kind of speak to that directly. But from our conversations, and certainly September, the workshop at the end of September, which probably folks from this group were at, there's still a lot of issues with the main stem and the crossings, how the egress and regress is going to work, which all, again, I was kind of focusing or stressing, ties into how you do your restoration in the main stem. I suspect there's still some work to be done on the tributaries with more structures and really assessing how well those structures are working. The limited assessments we did at the end of September for like Switchback Canyon, the vegetation was doing very well. The willows that were planted in the channels and the channel margins. So it has some really good aspects of really trying to stabilize those tributaries. But I think we need to reassess and continue to assess. So the other aspect of that, and I know from the conversations with the Pueblo, they really want to try to do some modifications to these gabion basket structures, potentially for fish passage, but also just for aesthetics and stability of the structures. And then I think, besides the egress, regress, and these crossings across the canyon and up the canyon, the ponds are a big issue for them as well, wanting to reestablish these wetlands and these areas for fishing access. And so I think there's still a lot of work to be done. And hopefully I didn't profess with this presentation that they are done, because I know they've got a lot more grants and other projects kind of moving forward to reestablish these roadways, ponds, maybe modifications to structures. And from an engineering with nature perspective, that's really what we're trying to help them kind of get through. Interestingly, the regulatory question about FEMA and the floodplain, there have been issues with some of the stream bank work that's been done in the canyon as well. And so from a permitting perspective. And so I think we've helped kind of, I won't say mitigate, but help kind of get through some of those permitting questions and issues as well.
So thinking about, what work still needs to be done, I went to that presentation the end of September, the year before last. And one thing that was mentioned is that some of these structures have been built multiple times. You capture sediment up to a certain point, and then you have to build another layer of sediment capture structures to continue building up these channels that have been really severely eroded. So I guess I'm curious, how much washout of kind of these built structures and the mulch materials did you see following large flood pulses? And have you seen some areas that need to be engineered multiple times?
Yeah, I think the answer is from what we saw just in September on Switchback Canyon, and that's just really a small population, there really weren't too many structures that had failed, if any, fully. The vegetation had really reestablished very well. I guess our biggest question, and that again, that's a small sample size, but the biggest question is how many flows have we really had since these structures were put in? And I don't think we've had an awful lot, basically since they've been put in. And that's based on some of the conversations with the Pueblo and the Albuquerque Core District as well. So I think the verdict's still out, especially on some of these structures that really, really block the entire flow. Because when you block the entire flow, if you're actually catching the majority of that water, it's going to have to go somewhere, and it either goes through your structure, under your structure, or around it. And so, yeah, that it's still something we're assessing, and I think at this point we don't really have an answer for that question.
Yeah, so it sounds like with most of your answers here, it's still a lot of wait and see. This is definitely an ongoing process.
Yes.
So we are past the top of the hour, but we have a couple more questions. So if folks want to stay on, please do. Susan asked, is the Army Corps of Engineers actively sharing your lessons learned with other federal, tribal, state, and local agencies to help promote adoption into their own accepted practices and manuals?
The answer is we are certainly attempting to do that through the EWN program. I think you posted a couple web links, Rachel, earlier, I guess probably right away when the presentation started. there's links to the EWN webpage. And I think the partnerships that are being established through a lot of the wildfire recovery efforts. I have a colleague, Ian Floyd, in the CHL lab, who's kind of the lead for wildfire recovery research. And I know his group is working pretty closely with the Pueblos in New Mexico and some other states as well for wildfire recovery. So it's an ongoing process. I would say that we're probably learning as much from the Pueblos as they're learning from us. And so the applications, there's a large range of documentation out there. And so we are certainly trying to add to that with our EWN guidance, and more to come based on some of these projects where we're doing the research and doing assessments after these wildfire events.
Alrighty, I'm going to throw one more question at you before we get out of here. Do you know what the economic benefit is of using in situ materials to build various structures as opposed to trucking in material from out of state or further?
Yeah, this answer is kind of this is one I use a lot when I'm teaching, because it depends. It really depends on the site and the applications that you're looking at. In many of these locations on the tributaries in the Santa Clara Pueblo, the slopes are just very inaccessible from an equipment perspective. I'm sure there's some specialized equipment that could do it. I'm not sure what that cost would be. But from a labor perspective, if these structures can be successful long term, I think the manual labor, which is not easy for sure, but using those in situ materials, you have low cost materials. If they will last and stabilize things, the reduced cost is exponentially better than trying to come up into some of these areas and use heavy equipment and maybe materials that aren't native. That's another, I guess, point between using the in situ materials, the traditional ecological knowledge is many of these Pueblos aren't really that interested in bringing in foreign materials to the watershed. And so that could be a constraint as well. But I'm not exactly sure how to get a cost estimate on that kind of comparison, because again, the sites are so different. When you talk about those type of comparisons,
Yeah.
and applications.
Yeah, so it sounds like there are many different reasons why folks who are impacted by an event like this might want to consider using materials on the ground, natural and nature-based materials. And economics is just one portion of that. That's just dependent on each situation.
Yeah. Yep.
All right. Well, I want to thank you again one more time for the excellent presentation that you gave, for answering all of these questions, for coming on and joining the consortium and Wildfire Initiative today. I want to thank everybody who joined us as well. Again, we have a series of fire and wildlife webinars coming up over the next 6 months. Hope to see you join for that as well. And Chris, I'll definitely keep an eye on the work that you do in the future and hope to have you back. So thank you so much, everybody.
Yeah, thanks, Rachel. And if anybody has any questions, you've got my contact information.
All right. Thanks. Bye-bye.